moving with a speed V naught. Let me write it so that it'll be easy for us in our calculations. So V naught, I'm making it. It is moving with a speed V naught. And what is the state of it? This is a test. This block is a test. It goes, collides inertical and gets stuck to it. Gets embedded in it. Find the amplitude of oscillation of the block. Now, also find the time taken by the block to reach its upper extreme position after it by bullet. So there'll be some natural length for the spring will be there. Okay, and I'm taking this a natural length. Then it got elongated somewhere here. X naught, I'll take it. So what was the initial elongation? Initial elongation is X naught. Okay, now show all the things. So this is Kx. This is mg. Kx naught and mg. Okay, fine. Okay, after collision, so what will happen? Together, it will become 3m m by 2. Okay, mass m by 2. I'll change it. Now the total mass, it will become 3m by 2 combined mass. As it is inelastic collision, it will acquire, say, velocity v1. It was moving with earlier velocity v0. Let this be velocity be v1, or okay, let it be only v. Can you apply conservation of momentum? Let me, I think, okay, I can keep it here. M by 2 v naught equal to m plus m by 2 into v. So v equal to v naught by 2. V naught by 3. Okay, this will be the speed of the block after impact. Okay, now what is the still spring force? Spring force will be acting kx naught only. But how much of weight? Earlier it was mg, now 3 mg by 2. So what was the mean position? The earlier mean position, this was the mean position earlier. This was the mean position, earlier initial mean position. Now where the mean position will come? The mean position means what happened where the net force will be 0, no? So earlier kx naught was balancing mg. Now kx naught, can it balance 3 mg by 2? Not possible, no? So therefore next mean position should shift here. If this is x naught, so what do you expect now? It will be like a mean position will be 3kx should be equal to like a kx should be equal to 3 mg by 2. So definitely what is the value of x? 3 mg by 2k. And earlier what was x naught? X naught was mg by what is the new mean position? Let me write like this. Kxm equal to this one. Okay, where the new mean position? The new mean position will lie somewhere at this particular point. Okay, sir, what is use of that? You can understand very clearly. What is XM? XM is the not maximum. It's a new mean position. I don't know. Don't get confused with maximum elongation again. Maximum elongation, it's not that one. It's a new mean position it is. Okay, now what is this? New mean position. We'll write like this. This is the XM. All the things I'll measure. This is the natural length of the spring. Okay, I think, okay, there's a natural length of spring. Not needed. Okay, he has given this one. What is L naught? L naught is natural, relaxed length or natural length. Okay, able to understand now? Okay, what was our question now? First, we have to calculate the amplitude of oscillation. Okay, now look at this. This is the new mean position. So I'm interested more on this one. I'm new mean position after it. After collision, it again. Okay, this is something very important here. Now you see this one. Now, where is this block? After it, at t equals 0, it has the block is collision is going to take place. So is it at mean position, new mean position collision occurs, or at earlier mean position? At earlier mean position, the collision took place. Okay, can we calculate the amplitude? What do you mean by amplitude? Maximum displacement from the mean position. Okay, we don't know how much it is, so that has to be determined. So how to calculate? Do I know what is omega, new angular frequency? What is the new angular frequency? Omega equal to root of k by total mass of system 3m by 2, 2k by 3m. Okay, how to calculate amplitude? Do we know V? Yes, we know V naught by 3. Do we know omega? Yes, we know omega. Do we know the position of particle? So any equation is there relating speed, position, amplitude, all the quantities? Yes, we have a formula. V is equal to omega root of minus x square. All the things I should measure from mean position. New mean position of course. So what is V? V equal to V naught by 3. What is omega? 2k by 3m a square. We don't know x. How to calculate x? Anybody? Xm is equal to x naught plus x. So xm is how much? 3mg by 2k. X naught is mg by k. So therefore, what is x is equal to? Mg by 2k. I'll substitute that. Okay, with this solving this, I'll get the required answer. So this will be V naught square by 9. 2k by n a square mg by 2k whole square. Okay, let's. So this will be 3m v naught square. I think only this will not be there, no? mv naught square by 6k equal to a square minus m square. Okay, this is the amplitude. Okay, so fine. This what? Find the amplitude of oscillation of the block. No, also find the time taken by the block to reach its upper extreme position after it by bullet. What do you mean by upper extreme? Where it come to instantaneous rest. What is the time taken? From where I should measure the time from here. So where the block will come to instantaneous rest. I don't know. So for our understanding purpose, somewhere the block will come to instantaneous rest. I'll call this as amplitude. For our convenient purpose. So what is this time is asking? Sir, will it be a greater than xm? All I think we have to work out. We don't have think only since he has asked amplitude, we have brought it. Just for our convenient purpose, I'm showing the diagram. Huh? So time taken to move from this mean to, so is from after it to the this particular, not this is not asking this time, is asking this time. This upper extreme, this is a mean, this will be lower extreme. Is asking this particular time. Okay, how to bring this time? I think what is the only best method available? The circle method. the circle method is what advisable, no? So I come to the circle. Okay, this is the mean position, what we have. But after it is where it is not at a distance x, no? The particle is here, somewhere here. So this distance is what x, am I right? And this is what a, this is theta. What is the question that is asked? Time taken, this is what t equal to 0. And what is the time? Upper extreme. Is it A correct what I indicated? Anybody wants to show that? No, that A should be from here, no? From new mean position, no? The amplitude will measure from there. What is amplitude? What we calculated is this one. Okay, agreed. Okay, now let's come for this one. So we know amplitude. So we have to calculate that particular distance. So I think time taken, we don't know this. So let me take this is. This is x only. This distance is what x, no? So from here to here, yeah. Okay, there's a mean position. Okay, this distance will be amplitude. Okay, what is the time taken? So this will be theta. We have to find out cos theta equal to x by a. So what is x? Mg by 2k. Then time taken to complete one oscillation equal to theta by t. Solving this, substituting this value of theta there, we'll get the required answer. But we don't know time period. Again, now what is the time period? I think the new omega, we know it, no? From there we can get the time period. Let me go for calculation part. So t equal to theta by theta is what? Cos inverse of mg by 2ka. We know omega equal to 2 pi by t. So t by 2 pi will be 1 by omega. Anybody value omega? Omega we have, no? 2k by 3m. This is time. Okay, these are the some. You can't write, sir, I'll write some x equal to a sine omega t. Not possible. No? Better to take help of the basic concepts of this kind. Okay, we'll go for next one. Just it's a very good problem. So many things. So students, what actually happens is you have to think very dynamically. Yeah? So something about using this equation is very, very important.